what I'm going to do is use this question to actually, instead of doing the hypothesis test, to actually form a confidence interval. So let's say an educator randomly assigns students to a program in which some are going to use a new reading activity and others are going to use traditional methods. And then at the end, each of the groups is going to take a reading comprehension exam. And the idea is to see if the scores indicate that the new activities may be better, and if so, then how much better, how much higher on average do they score on this reading comprehension exam. So what I'm going to do is open the data in StatCrunch and then go under Stat, T-Stats. I've got two samples, and then I've got the individual data. Now, if I had the means and standard deviations and sample sizes, I would use with summary, but I have the individual data. So I'm going to put the new activity in the first sample, the traditional or the control group in the second. I don't want to pull the variances, and I want to do a confidence interval this time. And let's say that this is a preliminary study, and all I want is a 90% level of confidence just to sort of get started. Okay. Well, let's click Compute. And then what does this tell me? Well, the sample difference would be the difference in the two Y bars. So what I could do, let me go ahead and generate some summary statistics. So I'm going to do the summary statistics for these two things and then talk about those just a minute. So basically, if you take the difference in the two sample means, 40 minus 32.176, you're going to get that 7.8235 number. Okay, so that's the difference in the two Y bars right here. The standard error is going to be that square root of this standard deviation squared over 14 plus this standard deviation squared over 17. Okay, and that would be that standard error. Now, the degrees of freedom the computer calculates for you, so we would use 26 if we were using table T and trying to come up with a t-score to plug into a 90% confidence interval formula. And then when they do the subtraction, they get a lower limit of 1.5 and an upper limit of 14.1. So what would that tell me? What would a lower limit of 1.5 and an upper limit of 14.1 tell me when I know I'm doing new minus traditional methods in terms of these average scores? Well, with 90% confidence, I would say that on average, students who could be taught using the new method are going to score 1.5 to 14.1 points higher than students who could be taught using the traditional methods in terms of reading comprehension. So it does seem like the new methods are increasing reading comprehension of students, at least as measured by this standardized test. So hopefully this gives you an idea of how to calculate a confidence interval from independent samples in StatCrunch.